Okay, another thing that we're going to talk about that has to do with heredity is we're going to talk about pedigree analysis, because pedigree analysis is a really powerful tool for us to look at generations of families and see how a disorder has been handed down through those generations. We don't use it like a Punnett square. We're not predicting what is going to happen with offspring, but it does have some predictive power, because if we look back at a family's prior history, we might be able to tell if an individual is going to pass down a disorder or not. So let's start off by talking about the key here. So in this particular pedigree, an affected male is a red filled in square. An affected female would be a red filled in circle. And on pedigrees, you'll always see females as circles and males as squares. Then this blue says wild type, and that just means that they're not affected by the disorder. And wild type female, that means they're not affected by the disorder. So a couple important characteristics of a dominant disorder pedigree. First of all, the phenotype shows up in every generation. So you're going to see an affected individual in every generation. So you'll have at least one affected individual each generation. The other thing is that affected parents will have at least one affected child. So not every child that they have has to be affected. And these are parents. We can tell that by this horizontal line. The vertical lines coming down indicates the children of those parents. So this is generation 1, and if you look at generation 2, these parents have 1, 2, 3, 4, 5 children. 3 of those children are affected by the disorder, but 2 of those are not affected by it. All right, and then another thing that we know is that unaffected children do not have affected children. So if you look here, this unaffected child from these parents, all 3 of their children are unaffected by that disorder. So those are some of the keys that we can come up with when we're looking at a chart like this. We can also figure out alleles from this, okay? So this is a dominant disorder, so we could say that this person's alleles have to be homozygous dominant or heterozygous, okay? And then to not have that disorder, this person has to be recessive. So on these, if we're figuring out genotype, we could go through here and put the recessive alleles on all of these unaffected individuals. So that gives us a really good start when we are assigning genotypes. Then we can look and we can say, okay, well, these parents had affected children, but they also had unaffected children. So in order for them to have unaffected children that have both the recessive alleles, this guy, this dad up here, he can't be homozygous dominant. He has to have that recessive allele. So we know that he is heterozygous dominant for this trait, and we can assign those alleles to him. We can also come down into the next generation, and we can look at this affected male right here, and if we want to figure out what his genotype is, we can look at his children and we can say, okay, he has one child that's affected, but he has a child that's not affected, which means that his genotype is going to be heterozygous. Okay, the next type of pedigree we're going to look at is for a recessive disorder. Now, the recessive disorder means that the individual who is affected, so this one here, this is going to be the homozygous recessive genotype. And then this individual over here is going to have the dominant phenotype or genotype. Obviously, they have the dominant phenotype because they're not affected. Okay, so some some things that we can look at when we first are looking at this and we're trying to figure out if it's a recessive or dominant disorder. Unaffected parents can have affected offspring. So that's one of the first things we'll look for, because if you look at this set of parents right here, they had 4 children. 2 of them are affected, 2 of them are unaffected. Okay, these 2 are not affected. Okay, but yet they still had affected offspring. So that's a really good hint that it's a recessive disorder. The next one is that affected children can be male or female. So this is a recessive disorder, but it's not linked to the X chromosome because affected children are male or female. And it often skips generations. So when we look at this, we can see that this generation has no affected individuals and this generation has no affected individuals. So we know that there has to be some heterozygous individuals here because that recessive disorder is showing up in later generations. And then another one we're going to talk about is an X-linked trait. Okay, so an X-linked trait means that it's a recessive disorder and it's only carried on the X chromosome. Now, remember that females have 2 X chromosomes and males have an X chromosome and a Y chromosome. Okay, so this disorder will only show up if it's on the X chromosome. And for that reason, the disorder often affects males but rarely females, because in order for a female to have this disorder, she has to have both of the recessive alleles on that X chromosome. A male only has to have that one recessive allele, and he could be affected by this disorder. And so the disorder passes from mother to son. Okay, so the way that we're going to indicate this is we're going to use X capital N for normal, and then this male has a Y there that doesn't have an N at all because it's not carried on the Y chromosome. And this female here is not affected, so she's going to have X capital N and X lowercase n. Now, it's an X-linked trait, and but it's recessive. So she has this dominant N for the normal trait, which means that she's a carrier, but she's not affected by it. And the way that I know that she's a carrier is because this son of hers has X lowercase n Y. He's affected by the disorder, and so he carries that trait on his X chromosome, and he had to get that from mom. Dad's normal, he's not affected, he only has 1 copy of it, so he couldn't have passed on that recessive trait. Mom had to pass that on.